Hello there, this is an Algebra 2 video. It is Chapter 4, Section 1. And today we're talking about graphing quadratic functions. And we have done a little bit of this before in Algebra 1, so some of this should be reviewed, but I wanted to just kind of make sure that I went over some of the basic things about a quadratic function before we get started. In a quadratic function, the greatest exponent of the function is 2. So you can see here, this is what we call the general quadratic function. It has a quadratic term, which is the ax squared term, which is where you have the highest exponent of 2. It has, or can have, a linear term, which is the bx, x to the 1 power being linear. And of course, the c represents the constant term. And so you'll notice that it says where a does not equal 0. Because if a was 0, then this term would not exist, and then this wouldn't really be a quadratic function anymore, because it would just be linear with x to the 1 power or a constant. So it's important that the a not equal 0. So again, it has the greatest exponent of 2, and when you graph a function that is quadratic, which we'll be doing here in a little bit, the graph is said to be called a parabola. So that's the name that we give to the graph of a quadratic function. And basically it looks like this. It's almost like a U-shaped graph. It can have, it can be facing upward or downward. And so we're going to go right into our first example, which is right here. It says graph f of x equals 3x squared minus 12x plus 6 by making a table of values. And so what you want to do is it's pretty important that you always pick negative values, positive values, and 0 when you're graphing to make sure that you have an accurate graph. Because the graph of a quadratic is a parabola, it is possible that if you only pick positive numbers, you'll only get one side of the parabola. So it's important to always use negatives, positives, and 0. You don't have to use a gazillion values, just make sure that you have a few of each. So I'm going to go ahead and start with my t-table, and I'm going to do x and y. We're going to pick -1, 0, maybe a 2, and a 3. And that should be enough. You could do more, but you don't necessarily have to. But you want to make sure you have negatives, positives, and 0. So what I'm going to do is I'm going to plug -1 into the function. So I'm basically trying to find f of -1 equals 3 times -1 squared minus 12 times -1 plus 6. -1 times -1 is positive 1 times 3 is 3. -12 times -1 is positive 12 and plus 6. So 3 and 12 is going to be 15. And then 15 plus 6 is 21. So we get that the y value is 21. It's a lot easier to plug in 0 because when you plug in 0, then this will be 0 times 3 is 0, 12 times 0 is still 0, you're going to get 6. So we'll have 0, 6 here. And then we're going to plug in f of 2. And you're going to get 3 times 2 squared minus 12 times 2 plus 6. So 2 times 2 is 4, 4 times 3 is 12, 12 times 2 is 24. So 12 minus 24 is -12 plus 6. So you're going to get -6 for 2. And then in a similar fashion, we try to find f of 3 by plugging in 3. So 3 times 3 squared minus 12 times 3 plus 6. In this case, 3 squared is 9. 9 times 3 is 27. 12 times 3 is 36 plus 6. 27 minus 36 is going to give you -9. And -9 plus 6 is going to give you -3. So we're going to have when x is 3, y is -3. So that's pretty much that part. And so then we're going to come over here to your graph, and we're just going to plot those points. -1 and then 21 is going to be way off my graph because you can see I'm going 2, 4, 6, 8, 10, 12, 14, 16, 20 is going way over here, maybe like up here somewhere. And then we have 0, 6, 2, 4, 6. And then we have 2, -6. So I'm going, this is going by 1, so this is 1, 2, but here I'm going by 2s. So 1, 2, and then -6, 2, 4, 6, we right about here. And then 3, -3, 1, 2, 3, and -3 will be right about here. So what you're going to end up with is this parabola that looks kind of like that. Alrighty, so that's pretty much how you graph a parabola by making a table of values. You just want to find the x values. Remember to pick negatives, 0, and positives, and then you just graph the resulting coordinate pairs and connect the points with a smooth curve. It's not supposed to look like a V. It's not an absolute value graph, so don't try to make this a sharp V. It should have this nice curve going on right here. So now we're going to let you do this do-it-yourself part A and part B. And then we're going to go on to some characteristics of quadratics. So here we have, I took this straight from your textbook. So you can see here, you want to make sure you have this in your notes, that we're going to talk about the characteristics of a parabola. One of the things that you'll notice about a parabola is it has this symmetric quality to it. And so basically what happens is you can draw this imaginary line, which you see here with this red dashed line, that basically goes through the middle of the parabola. And we call that point the vertex. And so this axis of symmetry goes through that vertex, and what you see is a mirror image, a reflection, if you will, so that whatever's on the right of this line, the exact same thing will be on the left of that line. And we call that symmetry. So when you have, again, the general function ax squared plus bx plus c, we can say a few things about this function. Is one, to find the y-intercept. Whenever you find the y-intercept, whether it be with quadratics or linear functions or any kind of function, when you want to find the y-intercept, you basically want to find the place where it crosses the y-axis. And you can see here the y-axis, and this is the point where it's crossing the y-axis. The x-coordinate of any point that is on the y-axis will always be 0. And that is why when you are finding the y-intercept, your method of doing that is by replacing the x with a 0, because the x-coordinate here is 0. And so when you do that, if you replace the x's here with zeros, then you get that this term, ax squared, will be gone, and this term will be gone, and all that will be left is c. So the y-intercept of a quadratic function will always be the constant term, which is c. The equation of the axis of symmetry, we have a nice little formula for that. The equation of the axis of symmetry, you can find this equation by taking negative b divided by 2a. So when it says b and a, it's referring to the coefficients here of b and a. So the formula for that is negative b over 2a. And it just so happens that because the axis of symmetry goes right through the vertex, the x-coordinate of the vertex is also negative b over 2a. You can find the y-coordinate by then taking your x-coordinate and plugging it into the original function and finding your y value. But I wanted to make sure that you had that information there. So now we're going to go on to our example 2, and it says consider f of x equals x squared plus 4x minus 3. And in part A, they want us to find the y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. So we're going to get started here by finding the y-intercept. We said before that to find the y-intercept, you would have to make x equals 0. But if we do that, we're looking for f of 0. We're going to get 0 squared plus 4 times 0 minus 3. And remember, 3 minus 3 is the value of the constant for this function. So it just so happens that 0 squared is 0, 4 times 0 is still 0. So f of 0 equals negative 3. Or in other words, the y-intercept is x0, y negative 3. There is my y-intercept. Okay? Now to find the equation of the axis of symmetry, we need to do x equals negative b over 2a. And in this case, the b value is 4, so we're going to put a 4 in that spot. And the a value, because there's nothing in front of the x squared, is 1x squared, so the a value will be 1. And then we just simplify this, and we get negative 4 divided by 2, which is basically negative 2. So the axis of symmetry is x equals negative 2. Now remember that when you get, it's asking you for the equation of the axis of symmetry. That means that when I ask for the axis of symmetry, you can't just write -2. You have to write it as an equation, which means you have to write x equals -2. So this is actually the axis of symmetry for this equation, but the x coordinate of the vertex is the same as the axis of symmetry. So for the x coordinate of the vertex, here's vertex, the x coordinate of the vertex will also be -2, and then it would be up to us to find the y value. In this example, they're not asking us to do that, but that's what we would normally do. After we find the x coordinate of the vertex, we would take that -2 and plug it into the original function and find the y value. In part B, we'll get a chance to do that because it says, make a table of values that includes the vertex. Now, the reason why I like doing graphing this way instead of the example 1 way is that with example 1, we had to use 4 points, 4 values, and sometimes you have to use more than that to get an actual accurate graph. But when you use the vertex as your center for the t-table, you can actually minimize your work to just 3 points. Always placing the vertex, which we said earlier was -2, always placing the vertex in the center of that t-table. So when it says make a table of values that includes the vertex, we want to strategically place the vertex in the middle. And then we want to, because of the symmetry that surrounds the vertex, we want to make sure that we pick 1 point to the right of the vertex and 1 point to the left. So here is basically where -2 is. We're going by 2, 4, 6, 8, 10. So here's -2. If we go 2 units to the right, we'll be at 0. That's a good point to pick. And if we go 2 units to the left, we'll be at -4. So what I'm going to do is I'm going to strategically pick -4 and 0 to be the other points on my graph. And then I'm going to use symmetry because I know that plugging 0 into the function is really simple. We already know from over here that the y-intercept was when x was 0. So I'm going to get 0, -3 as my value for here. And because they're symmetric, if you recall over here, because they're symmetric, I should be able to pick whatever is, if this is -3, then this guy, which is equidistant from the vertex, will also be -3. So the only thing left for me to do is to figure out what f of -2 is, because that is, I think it was 3x squared minus 12x plus 6, if I remember correctly. Let me go back here real quick. Oh no, x squared plus 4x minus 3. I was using the other example, sorry. So let's, so it was going to be x squared plus 4x plus 3, and I'm still not sure that I got that right, plus 4x minus 3. So plus 4x minus 3, so we're going to plug this guy in there. And I need to replace my x with a -2 here, like that. And so I'm going to get positive 4 minus 8 minus 3, but 4 minus 8 is going to give me -4 minus 3, I'm going to get -7. So -2, -7 is the actual vertex in this example. And if you want, you can even test that when you plug -4, you will in fact get -3. But we're going to use that to graph. So we have the -2, and then -7 is going to be 2, 4, 6. So -7 is right in the middle here. And then we're going to do -4, -3. So -4, -3 right about here, and 0, -3. So you'll see that that's symmetry happening there. And there's my graph. So it says here to make the table of values in part B. In part C, it wants us to use that information to graph the function, which is what we just did here. So now we've completed that example, and you can try, do it yourself, number 2. There is a part A here, and a part B and C there for you to do. And then we're going to go do example 3. But first, we want to make sure that we talk a little bit about, there we go, some more characteristics of quadratic functions. As we mentioned earlier, the graph of a quadratic function is a parabola, and here you see two examples of a parabola. These are basically the only two options that you have when you have a parabola. And basically, either the parabola opens up, as I mentioned earlier, or it opens facing down. And so the difference between the two is this A term, the quadratic term that we talked about before. If this quadratic term is positive, then it's going to open upward. And if it's opening upward, this point on the graph, which is the vertex, is also the minimum point on the graph. It's the lowest point on the graph. And then if that quadratic term is negative, then that would mean that you would have this upside down parabola basically, and then this vertex point would not be the minimum, but it would be the maximum or the highest point on the graph. So you know which way it's opening based on the sign of ax squared. And so if it's a positive, you know you're going to have a minimum, and if it's negative, you know you're going to have a maximum. The other thing that you can tell from looking at these graphs is something about domain and range. The domain of a parabola or of a quadratic is always going to be all reals. Any x value, whether it be negative, positive, or 0, can go into the function. But the question is about the range of the parabola. So for the range, you'll know that sometimes they ask you what the range is. And if they do that, what you want to be looking for, sorry, I'm not sure what that letters came from. So the range, you want to know what the possible y values are. And so you're looking at the y-axis. And since this is the lowest point on the graph, it means that whatever number this is, your range is going to be greater than or equal to that value. In the case of the negative parabola, the reverse is true, because now this is the highest point on the graph, so your range will be from this point down. So if this number was 5, for example, then the range of this function would be y less than or equal to 5. All values of y such that I kind of wrote that wrong here. Let me write this correctly here. So for your range, you would have all y such that y is less than or equal to 5. If this happened to be the value 5 here, then you're saying that the y values will be 5 and below. It will never be higher than 5. In this case, let's just call this negative 3. Then in this case, you would say the range would be all y's such that y's are greater than or equal to negative 3, because they would start at negative 3 and then go above, but never go below. And that's how you would apply the range to this kind of a function. So now we want to go back to example 3, because it says consider f of x equals negative 4x squared plus 12x plus 18. Determine whether the function has a maximum or minimum value. You can determine that based on the fact that the a value here is negative 4, and because it's negative 4, it means that our graph is going to be opening down like this, and so you're going to end up having a maximum as opposed to a minimum. No parabola can have both. You either have one or the other. In part B, it says state the maximum or minimum value of the function. So now they actually want us to find the maximum or minimum value of the function. To do that, we have to find the vertex. So we're going to go x equals negative b, and in this case, b is 12, and a is negative 4. So we're going to get negative 12 divided by 2 times negative 4, which is negative 8. And we're going to get positive, and so 4 goes into 12 3 times, and 4 goes into 8 2 times. So you're going to get a positive 3/2. But that's still not the value of the function. That just tells us when the maximum is going to happen. It doesn't actually tell us what the maximum actually is. So now to get the actual value, you want to put 3/2 into the original function and simplify to get the value that you want. So 3/2 squared is the same thing as 9/4. So we're going to get negative 4 times 3 times 3 is 9, 3 times 2 is 4. These 4s are going to cancel, so you're going to have negative 9. And then here, 12 divided by 2 is going to be a 6. And 6 times 3 is 18. and then plus another 18. So that's going to be 18 plus 18 is going to give us 36, and then 36 minus 9 is going to give us f of 3 halves equal to 36 minus 9 is going to be 27. So the actual value, maximum value of the function is 27. The vertex is actually 3 halves, comma, 27. That would be the actual vertex. And the vertex happens when x is 3 over 2, or 1.5. But the actual value of the function is 27. So for part C, it says state the domain and range of the function. Now notice that we don't have to draw the graph to be able to answer this question, because as I said before, the domain is always going to be all reals for a quadratic function. But for the range of the function, that's where the maximum or the minimum plays a role here. So for the range of the function, we want to say all y values y's, and because this is a maximum, we want to go, we know that this value here is 27 on the y. So it's going to be 27 and below. So y less than or equal to 27, and that's how we know what the range is. Alrighty? So now we're going to have you try this little guy, and then we're going to go to our last example. But to do that, we are going to come here, because our last example is actually asking us to go back to the beginning of the lesson where there was like a little story problem. But what I've done is I've copied and pasted that example to the board here, so we don't have to go back and look for it. But here's basically example 4. It says Eddie is organizing a charity tournament. He plans to charge a $20 entry fee for each of the 80 players. He recently decided to raise the entry fee by $5, and 5 fewer players entered with the increase, because when it increases, I don't want to play anymore. So he used this information to determine how many fee increases. Okay, I'm really sorry about that. But you saw what the board said, so what I'm going to try to do here is, that's never happened before. Let me go back and see if I can fix it in a matter of seconds. If that doesn't work, then we're just going to have to do it without it. Oh, there it goes. Oh, there it is. I don't know what happened, but there it is again. So, as we were saying, we're going to want to use this information to determine how many fee increases will maximize the money raised. Whenever it tells you to maximize something, you pretty much know it's going to be a parabolic function. So here it says, how much should Eddie charge in order to maximize charity income, and what will the maximum value of the pool be? So basically what they want here is the x-coordinate. Here we're asking for the x-coordinate of the vertex, and here we're asking for the y-coordinate of the vertex, but we don't even have a function yet. So before we can do that, we need to figure out how we're going to get a function going here. So what you want to do is you want to create what your variable is. And so we're going to go with x, and I'm going to say that x is going to be the number of price increases. Okay, so basically he wants to maximize his profit. So you basically want how much you're charging times how many people are coming. And that product is what's going to create this parabola for us. So what we have is that we know that there are, that the fee is currently $20, but he's thinking of increasing that by $5 each time. So see, he recently decided to raise the entry by $5. So he was charging $20, and in addition to that, you're going to add $5 times x. So basically what this represents is this is the price increase, how many times he increases the price. And every time he increases the price, he's increasing it by $5. So if he increases the price 2 times, then he's basically added $10 to the 20 that he already had. If he increases the price by 7 times, then he's going to be adding $35 to what he already started with. So I hope that makes sense. So that's where the 20 plus 5x comes from. And then you have the players. He has 80 players to begin with, but in the case of the players, every time he increases the price, 5 fewer players enter the tournament. So in that case, it's going to be decreasing. So the price is increasing, but the players are decreasing. And they're decreasing at 5 players per increase. So again, if he increases it 2 times, he's going to miss, or he's going to lose 5 players each time. So he's going to lose 10 players, and he would only have 7 left. So I hope that makes sense. So players times the fee is going to be his profit. So this is where y equals that. So now what we want to do is actually have multiply this all out so that we can get the equation that we need. So I'm going to go ahead and put that on here. I already did it earlier, and so if you don't trust me, you can always do it yourself, but I can assure you that it's going to be right. So when we go 20 plus 5x, I can pull it up here on my calculator, which I did this a little while ago. 80 minus 5x, we're going to get negative 25x squared plus 300x plus 1600. This is the equation that we end up with. And so to find the vertex, you want to go x equals negative b over 2a. And in this case, b is 300 and a is negative 25. So we're going to get negative 300 divided by 2 times negative 25, which is negative 50. And we're going to get a positive, and 300 divided by 50 is 6. So how much should Eddie charge in order to maximize charity income? He's going to have 6 price increases. That's 6 times 5, right? So that's this right here. So what's 20 plus 5 times 6? That's going to be 20 plus 30, so $50. $50 is going to be how much Eddie should charge in order to maximize charity income. And if he does that, what will the maximum value of the pool be? It's going to be plug 50 into the function and see what we get. So we're going to go ahead and do that. They now want to know what the y value is for my function here. So we're going to plug 6 into this guy here. So negative 25 times 6 squared plus 300 times 6 plus 1600. And we're going to get 6 squared is 36. So 36 times negative 25 is going to be negative 900 plus 300 times 6 is 1800 plus 1600. So negative 900 plus the 1800 is going to give us just 900, and then that plus the 1600 is going to give us 2500. So the actual pool of money is going to be $2,500, and that's basically how you do that. So in a very similar fashion, we want you to do this do-it-yourself number 4 question. It's just talking about what if Eddie has a different tournament. And so once you have completed this do-it-yourself question, you will have completed your notes for this lesson, and I will see you in class, and thanks for watching.